Good morning, sir, and everyone. I'm Vijeta, and today I'll be presenting about Kirchoff's current law. And two problems I'll be discussing on Kirchoff's current law. So I'll begin this video with telling what Kirchoff's current law is. So there are few laws which we are required to follow in order to solve any kind of circuital analysis. So there's two types of laws, which is Kirchoff's current law and Kirchoff's voltage law. And Kirchhoff's current law states that when two currents are entering a junction or any number of currents are entering a junction, it is equal to the currents exiting the junction. So as you can see in this diagram, there are two currents I2 and I3 which are entering the node. Junction and node have a similar meaning. So yeah, uh, I2 and I3 are entering the node. So we can write as I2 plus I3 is equal to I1, or summation of I1, I2, I3 is equal to 0. So this is the basics of Kirchhoff's current law. And there are 2 points which we need to remember before we solve Kirchhoff's current law, which is if two voltage sources are connected in this way, we need to add the two voltage sources. That is, if the positive is connected to the negative, or the negative is connected to the positive, then we need to add the two voltage sources. And if the positive terminal is connected to the positive terminal, or negative terminal is connected to the negative terminal, we need to separate the two sources. So keeping these small points in mind, we'll start with first problem, and we'll learn uh, as we go on how to solve and how the Kirchhoff's current law applies to solving any kind of circuit. So as you can see here, we have a circuit. We have three resistors and three voltage sources. And to start by solving this, uh, what we'll do is voltage at this point, this node. Okay, so we are assuming that the voltage at this node is at higher potential. So let us name it as VA. So VA is at higher potential. So whenever a voltage source is at higher potential, the current flows from the voltage source to other branches. So from VA, the current flows in three directions. So we will be applying KCL to the this node. And when we apply KCL to this node, what we can write is that. So before this, a small topic which we need to know is Ohm's law. So Ohm's law states that V is equals to IR. It is a formula given by Ohm's law, and it can also be written as I is equals to V by R, which is used in Kirchhoff's current law. So I is equals to V by R, and here we can see that voltage at A is at higher potential, and here it is at higher potential. The middle branch is at lower potential, and the last branch is at higher potential. So we'll write according to the notations which we have given before. So VA minus 2 volts by resistance plus VA 1 volt by 4 plus VA minus 3 by 6 ohms is equal to 0. This is the final equation we are going to get because there is only one node in this whole circuit. And after we solve this, what we will be getting is that VA is equals to 22 by 18, which is equal to 1.22. So as we only have one variable, we can easily solve this equation. And let us go to next problem. So this is the basics of Kirchhoff's current law. So we'll be looking at more problems which has more number of nodes and a current source. So this is the second problem we have at hand. And in this problem, there are two nodes and three resistors, three voltage sources, and one current source. So here, what we'll be taking is, so this is VA. Let us assume this is VB, and so here we can see that there's a current source where the current is flowing in this direction. So the current flows in this direction, and then as this is at a higher potential, it goes, the current flows from here to left and right branches. So let us first analyze the first node using KCL. What we'll be getting, let's see. So VA minus 4 by 1 plus, so we are taking this VA minus VB by 4. And as this is coming towards the junction, we'll be writing it on the other hand of the equation. So 6 amperes. And we don't have any voltage sources in that branch, so we'll be just writing 6 amperes. And this is one equation which we have got. And the second equation is dependent on VB. So assuming VB is at higher potential, the current flows from VB to other branches, which is something like this. So what we can write is VB minus VA by 2 plus VB plus 2 by 3. As this is at higher potential and this is at lower potential, we'll be adding them. And next is VB minus 3 by 4 equals to 0. So these are the two equations which we got. And when we solve these equations, so let us solve these equations for this problem. VB value equals to 2.322. So this is how you calculate VB, and substituting VB in this, you'll get VA, which is equal to 4.86. So in this way, we can calculate the node voltages using KCL. And there's also one special case which is known as a super node, which is the case where there are two junctions. I mean, there's a VA and VB node, and there are resistor and voltage source in between V and. So we can't just directly do VB minus VA by resistance because there's a voltage source in between them. So this is known as supernode. Thank you for giving me this opportunity to present this topic. Thank you, sir.